Thanks for joining me on Fascinating Frontiers, episode 54 for April 18th, 2026. Let's look at what's new across the frontiers of space and science. NASA picks Falcon Heavy for ESA's Rosalind Franklin Mars rover despite its own proposed budget cut. NASA has chosen SpaceX's Falcon Heavy to launch the European Space Agency's Rosalind Franklin rover in late 2028. The decision comes because the rover relies on NASA radioisotope heater units. Those units require a United States launcher under current regulations. This choice holds even as NASA proposes canceling its financial contribution to the overall mission. It really highlights the complex geopolitics woven through international space projects these days. On one hand, you have tight budgets and shifting priorities at home. On the other, you see how hardware commitments can lock partners into cooperation that outlives any single funding cycle. I find it fascinating how these practical engineering necessities sometimes override the headlines about funding cuts. While Europe prepares for Mars, NASA is busy moving giant hardware here on Earth to get ready for the next big lunar landing. NASA transported the mobile launch tower from the Artemis II mission into the Vehicle Assembly Building using Crawler Transporter 2. This move clears the pad and officially kicks off stacking operations for Artemis III. Artemis III is planned as the program's first crewed lunar landing. It follows the successful Artemis II lunar flyby that we have all been celebrating recently. Watching these massive crawler transporters inch along at a walking pace always reminds me just how enormous the scale of lunar return really is. Every careful meter the tower travels represents years of planning and testing coming together. The engineering precision needed to move something that tall and heavy without damaging a single interface is genuinely impressive. This progress shows the Artemis program is marching forward step by step toward putting boots back on the moon. Speaking of Artemis hardware performing well, we just got excellent news about the heat shield that will protect astronauts on the way home. The Orion spacecraft's heat shield showed only minimal charring after the record speed re-entry from Artemis II. Commander Reed Wiseman confirmed the shield performed exceptionally well during his post-mission debrief. This result clears one of the last major technical hurdles standing in the way of crewed lunar landings. Heat shields have always been one of those make-or-break technologies for returning from deep space. Seeing such clean performance after the fastest re-entry any Orion has ever experienced gives the whole team a lot of confidence. It means the thermal protection system can handle the punishing temperatures and speeds we will face on future missions. That kind of validation is exactly what engineers live for because it turns simulations into proven reality. While we are preparing for future lunar trips, a pair of instruments that have already been gathering critical data for deep space missions just hit an important milestone. Instruments deployed from the International Space Station a year ago aboard a SpaceX Dragon are measuring the deep space radiation environment. These detectors have now completed 1 full year of continuous data collection. The information they are sending back will directly inform better shielding designs for upcoming Moon and Mars missions. Radiation remains one of the toughest challenges for long-duration human spaceflight. Every new data point helps engineers understand exactly how particles behave far from Earth's protective magnetic field. The results are already being folded into next-generation spacecraft protection strategies. It is quietly remarkable work happening on orbit that will pay dividends for every crew that follows. Radiation is one of the biggest challenges for long-duration missions, and out in interstellar space, an even older spacecraft is now facing its own power crisis. Engineers turned off the low-energy charged particles instrument on Voyager 1 on April 17th to conserve its dwindling power supply. The spacecraft is now nearly 49 years old and traveling through interstellar space. It will continue operating its 2 remaining science instruments for as long as possible. Commands take nearly 23 hours each way at its current distance. Every watt saved today could extend operations into the early 2030s. After 48 years of continuous operation, the low-energy charged particles detector has been switched off because the plutonium power source produces less electricity every year. The team is carefully rationing what remains so the probe can keep talking to us from beyond the sun's influence. With only 2 science instruments left active, they are prioritizing measurements that cannot be duplicated anywhere else. If you could send one final command to Voyager, what would you ask it? That is the question I have been turning over since I read the news. Maybe a simple thank you for everything it has shown us about the edge of our solar system. That careful power rationing on Voyager is a perfect bridge into something that really puts the scale of deep space engineering into perspective. You know what blew my mind when I looked into this? If you could line up every watt of electricity Voyager 1 still produces, it would barely run a single old-fashioned light bulb on your porch. Yet that trickle has kept a machine alive and transmitting for nearly 5 decades across more than 24 billion kilometers. The spacecraft carries 3 radioisotope thermoelectric generators filled with plutonium-238. As the plutonium decays, it gives off heat, and special materials turn that heat directly into electricity with no moving parts at all. Every year, the fuel produces about 4 watts less than the year before, so mission controllers have been turning instruments off one by one in a long planned sequence. Imagine riding along with one of those last 2 working detectors. It is measuring particles that have traveled for hundreds of thousands of years from other stars, now drifting through the almost perfect vacuum beyond the sun's influence. The temperature out there hovers around 3 Kelvin, colder than anything we can easily make on Earth. Meanwhile, the spacecraft's own systems must stay warm enough to function using only a few hundred watts total. The real mystery that keeps engineers awake is exactly how long the plutonium will keep producing usable voltage before the last instrument falls silent. We know the curve, but we do not know if some unexpected chemical or material change inside the generators will cut the mission short before the physics says it must. It is remarkable that a spacecraft launched in the 1970s is still teaching us while brand new rockets are rolling out this weekend. Blue Origin is aiming for a launch on April 19th of its New Glenn rocket from Cape Canaveral. The payload is AST SpaceMobile's Bluebird Block 2 satellite. This mission will mark the first reuse of a New Glenn booster. Reusability has become the name of the game in modern rocketry, and Blue Origin is now stepping firmly into that arena. Seeing a brand new heavy-lift vehicle already targeting booster recovery on only its second flight shows how quickly the industry is evolving. The success or challenges on Sunday will be watched closely by everyone working on sustainable access to space. While Blue Origin prepares for reuse, SpaceX is keeping its launch cadence high with another Starlink mission. SpaceX is preparing a Falcon 9 launch from Vandenberg Space Force Base on April 18th. The 4-hour launch window opens at 7 meters Pacific time. The rocket will deploy 25 Starlink satellites into orbit. Sonic booms may be audible in parts of California as the booster returns. These regular Starlink missions have become almost routine, yet they represent an incredible infrastructure achievement. Every new batch of satellites strengthens the global network that now connects remote communities and supports countless users. The cadence we see from Vandenberg and Florida keeps reminding me how operational spaceflight has truly become. And finally, on the other side of the planet, we have news from China's human spaceflight program. The 3 astronauts aboard China's Tiangong space station will remain for an extra month after careful review. Their total mission length will now reach about 6 months. The extension allows additional time for scientific experiments already underway. Shenzhou 21 is another step in China's steady expansion of its long-duration human spaceflight capabilities. Giving crews more time on orbit means more data on how the human body adapts and how equipment holds up over extended periods. It also shows how mission planners are balancing crew health with the desire to maximize scientific return. Comparing the operational tempo across different space agencies is one of the most interesting parts of following this field right now. Before we go, keep an eye on Sunday's New Glenn launch as Blue Origin attempts its first booster reuse. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I am Patrick in Vancouver. See you tomorrow. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice using ElevenLabs. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.
Drifting softly through the black.